let's talk about one of nature's loudest and, it turns out, most brilliant mathematical secrets. It's a story about this really strange bug and a hidden code that somehow connects the forest floor to your online shopping cart.
Oh yeah. If you live in the eastern United States, you probably know this face. And you definitely know the sound. After years and years of silence, the ground just erupts. Billions, maybe even trillions of these red-eyed insects crawl out for a few short weeks. It's just a deafening, high-decibel party. And then they all die. It's a total sensory overload. But here's where things get really wild. These ancient insects are using a mathematical trick for survival that we as humans only recently figured out how to use to protect our most valuable digital secrets. So the big question is, what on earth could this bug possibly have to do with your credit card? To get that, we first need to just appreciate the sheer scale of this event. In places like Tennessee, all across huge parts of the eastern US, the emergence of the periodical cicada isn't just a thing that happens, it's an overwhelming force of nature. I mean, let's talk about density. We're talking up to 350 cicadas per square meter. That's like hundreds of them packed onto a single welcome mat. Now imagine that scaled up over thousands of square miles. The numbers are just astronomical. Their survival strategy is really simple. Overwhelm your enemies. So many come out at once that predators can eat until they're literally sick of them, and there are still millions left to carry on. And their life story, it's just bizarre. Get this, they spend almost their entire lives, either 13 or 17 years, underground, just quietly feeding on tree roots. Then, all at once, they emerge for a few frantic weeks of singing and mating, and the noise. The male chorus can get over 95 decibels, which is loud enough to actually damage your hearing. And we've known about them for a long time. People from the Royal Society were documenting these strange insects way back in 1665. So the crucial piece of the puzzle here is the timing. It's not random at all. There's a very specific and very, very strange pattern to when they show up. And this is where we start to uncover nature's hidden code. Here it is. This is the core mystery. They only ever emerge on 13 or 17-year cycles. Now, just stop and think about that for a second. There are no 12-year cicadas, no 15-year cicadas, no 16-year cicadas. Why? Why only those two specific, kind of weird numbers? Well, the answer is one of the most fundamental concepts in all of mathematics, the prime number. A prime is a number that you can only divide by itself and 1. You know, like 2, 3, 5, 7. 13 is a prime, 17 is a prime. The cicadas, through millions of years of evolution, somehow stumbled upon a deep, profound mathematical truth. So, okay, who cares? Why does being a prime number help an insect survive? Well, it all comes down to avoiding predators. Here's how it works. Imagine there's a predator out there whose population booms every, say, 2 years, or 3 years, or 4. If you're a cicada with a 12-year cycle, a number that's easily divisible by all of those, you're going to sync up with those predators all the time. It's bad news. But if your cycle is a prime number, like 13, you will almost never emerge at the same time as your predator's peak. It is an absolutely brilliant evolutionary strategy to stay out of sync with danger. All right, here's a fun little math problem for you. In some places, like Southern Illinois, you can get different broods overlapping. So let's say a 13-year brood and a 17-year brood both come out in the same forest this year. How long is it going to be until their descendants show up together again? The answer is 221 years. That's just 13 times 17. Their prime-numbered cycles are so good that they don't just help them avoid predators, they even help them avoid each other for centuries at a time so they don't have to compete for resources. It's genius. And this, right here, is where our story takes a sharp turn from the natural world straight into our digital one, because we humans have stolen this exact prime number trick, not to avoid hungry birds, but to create the very backbone of modern internet security. I love this quote from the mathematician Marcus du Sauterets because it just says it all. The very same mathematical principle that ensures the cicada's survival is what makes sure your financial data is safe when you click Buy Now. So how does this actually work online? Well, to put it simply, when you go to a secure website, it sends your computer a massive public number. We'll just call it N. Your computer then uses that number to scramble your credit card info into a secret message. But the website, and only the website, holds the private key, the two secret prime numbers that were multiplied together to create n in the first place, and only that private key can unscramble the message. The whole security system relies on a really simple quirk of math. It's incredibly easy for a computer to multiply two gigantic prime numbers together. But, and this is the important part, if you are only given that gigantic result, it is practically impossible to work backward and figure out which two primes you started with. And when I say practically impossible, I mean this. Look at this thing. This is a 617-digit number. It's public. Everyone knows it. But the two secret prime numbers that you multiply to create it, they remain hidden. There is no computer on Earth powerful enough to find them in any reasonable amount of time. This is the lock on our digital world. And that brings us to the final and, honestly, the most mind-bending twist in this whole story. Despite being so incredibly important to both nature and technology, prime numbers are still one of the biggest unsolved mysteries in all of mathematics. Think about it like this. Primes are the basic building blocks for all other numbers. Just like everything in chemistry is made up of atoms from the periodic table, every single whole number is just the product of a unique set of primes. They really are the atoms of arithmetic. And yet, we can't crack their code. We've known since the ancient Greeks that there are an infinite number of primes. But we have no formula, no pattern, to predict where the next one will pop up. They seem to appear almost at random. Figuring it out is so important, there's actually a $1 million prize waiting for anyone who can do it. So, from an insect buried deep under the forest floor, to the encryption that protects our entire global economy, primes are this universal code that remains a complete enigma. It really makes you wonder, doesn't it? What other profound secrets of the universe are hiding out there, right in plain sight, just waiting for us to notice?